in the streaming, or I can introduce you.
Okay, introduce me, so it's much easier now. Okay, do that.
Good. Hello, everyone. I believe we are live right now. Sorry for being a bit late. And so I would like to introduce you Dino Esposito, and he's going to talk about in defense of ASP.NET and the server side, the topic. So I would like you to do not forget to ask questions in Q&A section on the right side if you have. So good luck, Dino.
Okay, thank you for the introduction. Great to be here to talk in defense of ASP.NET. There is in the title of this presentation a sort of a quote for a popular piece of art. It's a quote from Shakespeare, Mark Antony, that speaks at the funeral of Caesar, killed in defense of him. So I want to be here in a much probably less noble scenario to defend ASP.NET and in general the server-side web development from the common perception that lives in the world. Which kind of a right do I have to be here speaking in defense of ASP.NET? I have personally a long history of being one of the people in the world that started talking about ASP.NET and demonstrating and using ASP.NET since the very beginning, so over 20 years ago. For many years in my career, I've been just a talker, a speaker, a trainer, a consultant, but I've never worked on a daily basis on any serious real-world development. This thing changed radically around 2020 when I took a position as the CTO of a sport tech company, and all we do is real world nearly 24/7 running operations in professional tennis and paddle. So if there is a tennis tournament, professional, high level, Grand Slam level tennis tournaments, as well as minor tournaments in the world, tennis and paddle, it's because people involved, players and staff, use our platforms. So I am now deep into development. All we have are web platforms written with ASP.NET, following architecturally speaking, the pattern of modular monoliths, and hosted on Azure. So this is the right I have to be here beyond all the books I have done on ASP.NET. So ASP.NET. In the history of web development, started in late 90s, to be serious, we first had a bunch of HTML files just deployed statically as individual files. Then PHP and classic active server page added a bit more of logic and made smart the solution of serving pages, but pre-generating content, making queries to databases on the server side. And then ASP.NET reached the peak of the curve, industrializing the generation of pages in the server. Since then, ASP.NET has become a core version, cross-platform version, but still it's called ASP.NET and still is related to Microsoft. So the common perception of this platform today is that it represents the legacy of the Microsoft-centric past that the industry, for some reasons, seems to be willing to forget. But the reality is different. The reality is that ASP.NET is still today an excellent framework that makes it particularly easy to move from a client-server vision to the web vision. It has a wide adoption, a huge installed base, and still today, if you have a chance to talk to component vendors in the industry, no matter they sell Angular, React, Vue components, most of their revenues, this is what they say off records, still come from the products they developed 10 to 15 years ago, still maintained for ASP.NET. So, in summary, I would like to say that the plus of ASP.NET is that it has the virtue of being boring. And you are boring in software because you are stable and you are reliable. And using you doesn't make anything exciting, but just functional to the results you want to achieve. Back now to the previous slide that shows the going on of hype in web development. Let's try to review the same curve, putting on it labels to describe more in detail the patterns of development being used. So at the bottom, where you have manual HTML being written, the output was, of course, pure HTML, JavaScript, and a bit of CSS. Then we ramp it up towards plain server-side generation of HTML via PHP and classic active server page. At the top of the curve, a desktop style flavor of development, which was all the rage with the original ASP.NET platform, in which, that's important to know, the slogan was no exposure at all to HTML. So one of the reasons, historically speaking, that made the ASP.NET original platform so successful for the time it was presented, so early 2000s, was just the fact that it made unnecessary to know details of any details of the web technology, so CSS, HTML, and JavaScript. At the time, the vast majority, I would say, of developers were coming from a client-server programming model. And they had they were experts in languages like C, C++, maybe Delphi, maybe Pascal, maybe Visual Basic, maybe Java, but were not expert at all with stuff like HTML, JavaScript, and even the weird thing called the CSS. Consider that you know the story about Java and JavaScript, the names. JavaScript was just a toy language compared to Java. That was the perception of this language at that time. So, and platform like ASP.NET that would make so easy for this kind of developers to do web stuff. And web stuff was all that the companies wanted at the time, because they were discovering e-commerce. E-commerce was a huge breakthrough for the industry. So at that time, every company in the world wanted to do e-commerce, and they needed a platform easy to use and effective to generate web content for the mass of developers of the time that were, for the most part, client-server devs. So ASP.NET was just the perfect fit. And the slogan was, you don't need to know HTML, no exposure to JavaScript and this kind of things. You just code in a visual environment in an event-based pattern. But after this peak, that was in the next decade, we are around 2010s, there has been a progressive attempt to put as much dynamism as possible in the server HTML pages. So resort more and more and more to JavaScript to do local client-side animations and page refreshes. So movement to put more HTML and smarter started. And at some point, there was the decisional point in which do we still need to use HTML? Aren't we looking maybe for something smarter and more sophisticated than HTML itself? Maybe XAML? That was the time in which Silverlight was extremely popular. Then something happened because we went totally back to the HTML, pure HTML development. I do remember very well that around 2015-16, I wrote articles for MSDN magazine saying CSS is dead. The future is teams or technologies on top of XAML to make decoration of visual elements easier and effective. I totally got it wrong. And we observed since the 2015 a progressive increase of JavaScript, HTML, the raw bare metal of the web. So we are back now to pure HTML stuff, and we focus on this. So today, modern web applications have a front end, a back end, and REST in the middle to make the communication. So on the front end, you have mostly JavaScript-based components that make calls to some sort of backend, an API backend, to grab and bring on the client side a lot of data. And this data is then arranged in a view using more or less sophisticated framework. So it's a very simple, basic schema. But this is the modern web application. But there is also now a postmodern web application, which is a lot more complicated. Well, there is still a front end. And what was originally the backend has been segmented in a bunch of distinct backends, each one essentially represents an API, not to mention that there could be, and often there is, yet another layer of API on top of all of them called the gateway. Not to mention that REST is often replaced by something called GraphQL, which brings on top of the gateway its own layer for reading and writing data that lives somewhere else. So the way in which data is collected from the server and brought to the client happens for the most part to serve the needs of the front end. So GraphQL enables the front end developers to make their own queries regardless of how the data is physically stored. So it's a total change of perspective. Backend developers count nearly nothing. All they have to do is put it into some sort of cache, all the data as easy as possible, and then it's the front-end developers that arranges the query. But the issue is that all this power to the client that comes at the cost of diminishing the power on the server at some point created some issues. So the page takes a lot to load. So smart idea, let's create a backend for the front end. And so we have now a bunch of frameworks, the most popular three, the red Angular, the blue React, the green Vue.js, each with its own backend for the front end, next Nuxt Universal. And on the server side, in general, people still believe that ASP.NET Core only used for the backend is a good option. ASP.NET Core is then regarded mostly, if not exclusively, for building web APIs. So endpoints to be called in some way directly by the front end. But now the point that I want to call your attention on is another. Why do we need? What is the concrete benefit of using a lot of JavaScript power on the client? If you go through the documentation, the summary articles that wraps up what's good and what's great on Angular, React, and the others, you find that, oh, they have a virtual DOM. They are smart because they have a virtual DOM, which is able to update only the segments of the view displayed in the browser window that needs updated. But if you don't know the history, the true history of the web, so how the web was developed and arranged, you find that virtual DOM is total, well, I'm supposed to say an inelegant, to use some inelegant wording here, is nothing special. It's exactly what you would do regardless, and what ASP.NET allows to do without all the ceremony of a framework that inside of it has an object, a big box, big sandbox called the virtual DOM. So now the basics of DOM programming, where DOM stands for Document Object Model. The DOM represents the internal hierarchy of objects that the browser, any browser, creates to be able to render anything to users. So to show something in the browser window, some code must be run that edits and changes the DOM. The DOM exposes a read-write API for some code to change it. This some code, given the internal architecture of browsers, can only be or can mostly be JavaScript. An option more recently, another option is using WebAssembly. But beyond WebAssembly and JavaScript, there are no other ways to edit, to update the DOM. Now, the DOM itself, the low-level API that every framework has to use because there's no other way of doing things, this DOM can be edited in two possible ways. One is changing the branches of the DOM using add, delete, node functions. So the tree has nodes, okay, and the API allows you to drop and attach or edit the content of individual subtrees, nodes. This is the fastest way. It's not so, easy to code, but it's the fastest way. Another way to edit the DOM is using the inner HTML property of node elements. So to inner HTML, as the name in a way suggests, you assign just a string, an HTML string, a fragment of HTML that internally the browser parses into nodes to be edited, appended, or deleted, and then applies those changes. So inner HTML requires an interpretation step done internally in the fastest possible way by the browser. And it's easy for you because you just, as a developer, pass it a string of text. Now, in which way Angular updates the DOM? Angular has a component called IV that essentially takes care of turning all the changes made to the representation of the page offered by Angular components into actual changes to be made to the DOM. React does exactly the same, except that there is, it maintains a copy of the browser's DOM in its own memory, which is still within the browser. And the programming model of React on which developers work on determines a number of changes. The virtual DOM component within the browser makes a comparison of diffs, the in-memory status of the DOM and the real status of the DOM, determines the changes to be done and applies the changes. So smart. Well, it's not so smart. It's a lot of work and a copy of the DOM kept in memory. Now, let's see what any plain old server-side based application for the web, for example, like those you can write with ASP.NET, requires you do. There is a plain HTML served as a string from a server-side generator to the browser. The browser renders it, creates the DOM, and then the server side can have incorporated a few pieces of JavaScript that just make the changes to the DOM. No intermediation, direct access, the possibility of running surgical, precise, extremely, direct changes with the minimum amount of work done on the client and the fastest possible rendering. But there's more. When it comes to when it comes to considering the effects of those frameworks like Angular, React, Vue, they are essentially browser in the browser. I remember very well when Angular, called Angular.js at the time, it came up, I think it was around 2010 or something. And all it was able to do was string building. So it was an engine written in JavaScript, hosted through a single JS file within all the pages that wanted to take advantage of this service. And they were there, and they were receiving, so this engine was receiving JSON data, XML data, and all they were doing was building a long HTML string and attaching those HTML strings dynamically generated after calls made via REST to the backend to the various nodes, the various pieces, the various divs, more or less empty, of the current page. But when people started experiencing this way of working, they said, oh, why not more? And more meant, let's create a single page application. So a single page that, like a desktop application, doesn't work by navigating from URL to URL, but lives there always in the same URL, but goes into different states depending on the actions taken by users. Oh, great idea, fantastic idea, except that it was going in a way too far from the original sense of the web, which was based and is still based on URLs. So you should be able to give a specific address, a specific pointer, and go to a specific state or a specific situation within the app. If you have a single page, there is no way for you to point the user to have a link that brings you to a different page. There is no way for you. You have to invent a completely new way to navigate within the app. So reinventing a link, an hyperlink mechanism within JavaScript was the next problem. And they did it. Essentially, SPA frameworks, SPA frameworks, single page application frameworks, grew to be a browser in the browser. And this browser in the browser is still done in JavaScript, which is not the fastest language in the world, and no matter the compilers that greatly anyway improved the performance of JavaScript. But there is more. There are three big issues, two more, the performance overhead. CO, content fetched and rendered after the page is loaded. How can robots map content to URLs? Impossible. Accessibility. You know that in Europe, next year, a year from now, expect fulfillment of accessibility standards become mandatory in much the same way GDPR was for privacy of data now 8 years ago. So accessibility has always been important. It will be even more important in the next 12 months, or starting from the next 12 months. When you use SPA applications, keyboard navigation and dynamic content, so dynamic content makes so easy to lose context, creating issues for people with disabilities. The same area attributes and semantic HTML, which is an extension to HTML just to help people with disability, are, well, often missed because nobody writes HTML anymore, but all HTML is written in terms of high-level components. A bug in the components propagates to what people see, creating possible and serious issues for accessibility. So there are these three big problems that React, Angular, and Vue, SPAA frameworks started to address. No matter, they are still so popular for reasons that honestly go well beyond me. It's not a technological reason. It's a trend. It's a trend in which to which many lead architects contribute when they think everyone uses Angular, why not us? Everyone is using React, is moving to React, why not us? And if you try to address the reality of web development and page rendering and bring to the table the benefits of frameworks like ASP.NET, but even PHP, they say, no, it's so 2000s, it's so old. We live in 2024, come on. You don't want to still rely on jQuery, what? That's it. So ASP.NET Core 8, the latest released and an incredibly fast rendering engine, is only good for API endpoints, not for the front end, because the old style server-side rendering is not trendy anymore. But now let me ask you a question. Why do we write web applications? Personally, I write web applications not for the sake of it, not for the pleasure of playing with technologies, but to deliver the service to customers. Personally, as I told you already, my purpose is enabling operations, everyday operations, nearly 24/7 operation, 365, 24/7 operations in tennis and paddle, professional tennis and paddles events that move $1 million in prize money and various expenses. So my point is not the technology, but using the technology in a savvy way so that things could be done. So the technology is just the means and the business is the end, not the other way around, as too often I have the feeling that things are going. So ideally, you write web applications, you work on web applications to provide problem solving, so business effectiveness, acceptable performance, great user experience, support frequent changes if they are required, and to simplify the onboarding of new developers on the team. These are the 5 golden points you should focus on if you are in your mindset giving maximum importance, maximum relevance to problem solving, and then are using the technology as a means and not as an end. If you focus on the sake of technology, then you want to use the latest and the coolest technology. You want to favor, for I don't know why, which reason, technology diversity is a plus to use many different things within the same project. You want to give freedom to developers, individual developers, no matter senior, junior, any developers should be free of using whatever pet technology they would like to use. In this case, business is the means to experiment with technology, but it's not how things like in the real world, as long as my experience counts. Okay, so now let's have a look at what ASP.NET has to offer, the good parts of ASP.NET for the front end. We have ASP.NET Core and Blazor. Both use a markup language called CS/HTML, and both rely on dedicated smart components, a sort of server-side web components called tag helpers. A tag helper is a C# class that you have total control of that acts as a sort of smart HTML factory and generates HTML, usually exposing properties that qualify the usage of it as component-based. In this CS/HTML tag helpers, there is handmade JavaScript and CSS. You code by example. You need to have self-discipline and as a single developer and team discipline. And for componentizing, you rely on in-house frameworks or languages, in case of Blazor, that are a smart level and like C#, and this allows you to use also libraries compiled by other people. In comparison, if you go for a front-end rich framework, then everything you produce is packaged in components you have a little control on, unless you have written those components yourself. You follow the programming model of the framework rather than being free of generating the HTML the way you like, and even in the fastest possible way. You have no control over all the routing done. You have no control, for example, in React on all the mess, all the extra work due to using the virtual DOM. Discipline is mandatory, it's mandatory, cannot be done without discipline, but it's not your discipline, it's the framework discipline. This could be great if you have large teams, maybe, because the discipline is one, no one in the company is responsible for that. It's the framework that dictates the discipline and the rules of this discipline for individual developers and team development. Everything you need is included in the bundle, which makes what goes into the browser at runtime even bigger. So now, what is, to cut a long story short, what is the reality, what we really need to have an effective web development? There is this specific component. So this screenshot presents a code snippet from a Blazor page. Blazor is the other newer phase of ASP.NET development. Blazor is a statistic framework, but easy to grab for everyone with ASP.NET experience. Essentially, it deploys a relatively small block on every page. Of course, it's downloaded only once and then cached. That brings the selected part of the .NET Core framework as a WebAssembly component. So you can run a native code through Blazor within the browser. The browser supports for programmability, JavaScript and WebAssembly. Blazor deploys to the browser a version of the .NET framework compiled to WebAssembly. So it means that every page you display, every DOM you render in the browser can interact with the .NET framework in the browser using the C# language. No more JavaScript at all. Then the page rendered, the Blazor page rendered in the browser should interact in some way with the server-side counterpart. And in the latest version, they introduced the render mode interactive server that essentially delivers what postmodern applications done with SPI framework that I mentioned earlier attempted to achieve in a much more effective way. Because you serve the page as a single string of HTML pre-rendered, which is the fastest. You do this without having a backend and a backend for the front end. You have just the classic backend and the ASP.NET CSHTML rendering engine, period. End of the story. You get HTML served in a single step without code to run on the client the first time. Fastest as ever. Then, what about the next steps as the user interacts with the page? The interactive server mode in Blazor application allows the framework to start sending WebSocket messages with a specific dedicated endpoint on the server so that the virtual DOM is maintained on the server and just commands, segments, pieces of HTML to be patched here and there to update the page are sent. It couldn't be faster. It's just surgical web development done for free at the sole cost of using ASP.NET as the endpoint and Blazor or the HTML-based ASP.NET front end on the client. No extra framework, zero or limited JavaScript. And if you use JavaScript, it's only the JavaScript necessary for minimal updates. No overall overhead at all. But now let's talk a bit more also on the ASP.NET for the backend. It has, in version 8 of the .NET Core, an interestingly fast runtime. Every new version releases a runtime for serving calls times faster than the previous version. Many people complain that if you go for ASP.NET on the back end, you need to have two rich endpoints that do a lot of ceremony. This is what controllers do. But actually, what the same people forget is that there is a lot you can do in .NET Core to control the weight, the actual weight in terms of memory overhead of controllers. You can cut short what controllers do before your code runs after a URL is called from the client side. The controller size, so to speak, can be normal, and normal is fairly rich because it allows a lot of flexibility, but still flexibility comes at the cost of runtime overhead. But it can be slim or it can be even empty. But you can also drop entirely controllers. Just writing code in a Node.js fashion or Python fashion. This is minimal API. So in ASP.NET, no excuses. Whichever programming model you like, you have it at an even better performance. And let's finish off this presentation in defense of ASP.NET talking about a quick comparison between Node.js and ASP.NET. Now, Node.js is a runtime environment that executes JavaScript and TypeScript code. JavaScript, always associated with the front end, can now run on the server everywhere, in desktop computers as well as cloud servers. Node.js is incredibly popular to be lightweight and event-driven and to have non-blocking capabilities that make it suitable for fast and scalable network applications. Non-blocking. Wow, great. And it's unique in this. Well, not exactly. Let's find out more about the blocking, non-blocking point. Node handles incoming requests in an event loop. So there is something that goes on and on and on and starts operation, go on, detects an operation, forwards the operation, and goes on and waits. So in a single thread, you have multiple tasks running. And well, single thread, multiple tasks running at the same time, it doesn't look like a smart thing that is possible, but yet apparently is like this. But what is ridiculous is that at the same time, the people who celebrate nodes dismiss ASP.NET because ASP.NET is really multi-threaded. And because it's really multi-threaded, it can really take advantage of multiple cores. Each incoming request takes a thread from a pool. Which one is best? Blocking? Blocking because a thread is blocked until that specific request is served, or the non-blocking that does everything within one thread. Here we go. So the top part is Node, the bottom is ASP.NET. When a request comes in nodes, there is the event loop that picks up tasks, and for each task determines an executor. And once the executor is being determined, the loop goes on and on, waiting for the next task to process. And the executor is put in charge of an executor. There are three types of executors: a timer callback, an IO operation, or a CPU task. Now, if the requested task is a CPU task, well, it means that the CPU has to work. You have to wait, period. Blocking or non-blocking or whatever it is, you have to wait, period. If it's a timer callback, then there is an operating system feature that sets up a timer. But you rely on the services of the operating system. Same if you use IO operations. Then you take advantage of the operating system capabilities. But now let's see what happens with ASP.NET. There is no event loop like the one in Node.js, but when a request comes in, it is there is a central dispatcher that picks up a thread, a free thread from the pool, and assigns to that thread the completion of the operation. Now, it can be an I/O operation or a CPU task. If it's a CPU task, the thread is blocked until the end of the task because there's no other way. The CPU has to do calculation or whatever the task specifically requires. If it's an I/O operation, so call a network endpoint or making a database query or waiting for another process in memory to terminate a given operation, the thread that doesn't wait for the I/O operation, it does not stays there blocked, but still waits for, uses an operating system capability to be notified of when the operation ends, and the thread returns immediately available to the thread pool. So it's exactly the same pattern as Node.js, except that ASP.NET is multi-threaded. And the point in common is not any magic that Node.js does, but the point in common is that both rely on capabilities of the operating system, be it Linux or Windows. In Windows, we are talking about something called completion I/O ports. So it's the same. It's the same. So there is no magic in Node.js. So feel free to use it, but you are still working in a single threaded environment versus ASP.NET. The difference is one: when you go Node.js, you get the non-blocking behavior regardless. That's the only possibility. In ASP.NET, you can have synchronous and asynchronous calls. If you opt for the asynchronous calls, you get exactly the same as Node.js. And if in ASP.NET you have minimal API, you also get rid of all the possible ceremony for controllers, and you get exactly the same thing. So to cut a long story short and to terminate the presentation, in general, when it comes to software development, avoid tunnel vision, but make sure that you don't fall victim of ideology, but you use your brains to figure out what you exactly need and which are the technologies available for that and how people is doing with that. And if what they are doing, other people you observe are doing, is really sensible and is not victim of the pleasure of trend. Clean design of the backend is key. And you can mount nearly any front end on a proper backend. Yes, thank you very much for that presentation. Let me see if there are a few questions, or maybe Tariq, you can help on this regard.
Sure, Dino. First of all, thanks for that great presentation. And there is a question in the Q&A.
Yep.
And Raju is asking that, isn't it too much easy to write web apps in React and Angular?
I don't know, because I mean, for me but I'm coming personally, and for the people that I trained myself is no, I would say exactly the opposite, because we can hardly figure out how it works because it's too far away from how web pages are rendered. And I personally make a point of training my people to understand how it works under the hood and then come to abstractions. So honestly, I don't know if it's really easy. But okay, I'm not saying that people should stop using Angular or React. But that my point was just talking in defense of ASP.NET to say that feel free to use Angular React if you believe that it's so easy, but don't dismiss ASP.NET because there is nothing really bad in it, and probably there is more from a structural perspective than other frameworks, because it has a lot less layers of code in the middle. Okay.
So thank you. And I don't see other questions. And okay, one more, sorry. And the question is, are you using front-end framework or Blazor on your current project?
We typically, most of our projects use the for the front end, the MVC pattern, so regular controllers. We have a couple of projects, but not critical in terms of the services they provide that are based on Blazor. Still, the jump from a classic server-side CHTML-based view to Blazor, there is a bit of gap. Nothing that is problematic to address, but still there is. So for the mere sake of productivity, to squeeze every single bit of performance out of developers, for the moment we tend to minimize but increase over months the use of Blazor.
Okay, 2 more questions. We have still time.
Yep,
And
it's okay for me.
it's the question is, how about multi-threading in Blazor WASM?
It's the same as in .NET, so it's multi-threaded, and it's up to you to creating threads. It's .NET, just hosted in the browser. Period. End of the story. That's it. As easy as it.
All right. And another question is, should we create a thread for explicitly or just using the thread pool for long background tasks?
Excuse me, can you repeat the question? I didn't get it.
Sure. And the question is, should we create a thread for explicitly or just using the thread pool for long background tasks?
Okay, no, in ASP.NET, the easiest way is just using async await keywords when you define endpoints. That's it. That's only, Microsoft did a good job of hiding completely the details, the nitty-gritty details of the thread pooling, blocking and not blocking of threads under this pair of keywords, async await, that you apply at the await is applied at any call that needs to open up in the end a completion port. Those are recognized by name, by convention name, having async at the end of the function name, the method name, and use async to label, to tag the controller method that acts as the endpoint. This simple trick enables you to take the most out of ASP.NET. Historically, the issue was that async await keywords in C# are relatively recent, and for many, many years, the support for asynchronous calls was in ASP.NET since the very first days, but it was so complicated and error-prone to implement that nobody used it until Microsoft introduced hidden under these new 2 keywords, which are basic syntactic sugar, the right support for asynchronous calls.
Okay, the last one is, I got several questions about this, but I think I can ask one of them. It's about the feature of Blazor. So is there a feature for Blazor, or will be the same feature like Silverlight?
The funny thing is that Microsoft dismissed officially Silverlight, but started from the Silverlight code base to build .NET Core back in 2014, 15, whenever. That's a funny thing that very few people know. But anyway, it's a piece of truth. I like to think that Blazor is Silverlight properly done. That's the way in which I would summarize things. Blazor is Silverlight properly done, and properly done means fully and natively integrated with browser much more than Silverlight was at the time, and providing essentially the same overall behavior with much better performance and much more support and commitment from Microsoft and care of development. There are many frameworks for controls that are coming up for Blazor. There's a Blazor Bootstrap, for example, which is great. So now effectively developing for Blazor is closer to the bare metal than with Silverlight, but equally effective and fast, I would say.
Okay, I said last, but another question comes up. So Mattia is asking, an Italian friend, the Python fast API is very simple and fast. Are you agree on that?
Okay. Minimal API in ASP.NET is exactly like that. So, I mean, go Python, go whatever you want, no problem. But don't say you go with Python because there is no alternative in ASP.NET. That was the point, the defense of ASP.NET. Minimal API is exactly provides exactly the programming style you are used to in Python or in Node.js. It's exactly that. You just write the code and endpoints executes and you write the code. That's it. No ceremony, nothing. Or in addition, you can have controllers, but yeah, that's it.
Okay. And this is asking that people are blaming performance of Blazor. Can it be a standard in the .NET ecosystem?
As far as I know, that seems to be the purpose of Microsoft investing in Blazor. But more than that, what I would like to point out is that beyond the technology, Blazor, this or that, is that Blazor for me is making extremely easy to implement a pattern that I like to call surgical web development. So making exactly the changes to the DOM that you need in a much faster and direct way than Virtual DOM in React. Virtual DOM is a mess. I mean, it's a smart idea, but it's just like, you know, you take a giant you have a gun to kill a hand. It's there, it's huge, it's smart, but everything passes through that. It's much faster if you go straight to the DOM. And Blazor is making this extremely effective and also offering a component-based programming model that is a plus.
Okay, so that was the last question. Thanks, Dino, for this great presentation again. So all the attendees, so see you in the next talk then.
Okay, thank you. Bye.
Bye-bye.